I'm going to present to you a new software released by Beta, DEAN. DEAN, the name stands for Design and Engineering, as it tries to bring the two worlds closer together. This is also depicted in our products map, where you can see all the software of the Beta suite. They are all involved in the CAE world, but we know that the data that they handle, the data that they generate, they extend beyond the boundaries of CAE and are also relevant for the CAD field. So we wanted to offer a solution, to offer a tool in order to be able to share the data to the CAD world. Now let's have a closer look at the goals, what drove this development, what made us develop this new software DEAN. As already mentioned, major goal is to be able and bridge the gap between CAE and CAD field. We know that in order to be able and produce and generate products, there is always the need to communicate. There's the need for communication among CAE and CAD people. And wherever there is communication, there is also room for misconception that can lead to delays or issues. And in order to address this issue, we need to have a tool that can facilitate the exchange of information between CAD and CAE in order to improve collaboration and boost design reviews and new product cycles. And to do this, we need to offer a tool that can allow the designers to understand what the CAE people are talking about, what the CAE proposals are, and they need to have a tool that they can feel comfortable with. Now, the target group of DEAN is actually both CAD and CAE people, as they both want a simple tool so that they can communicate, so that they can speak to each other. One could argue that post-processor tools could be a solution for this, but the rising complexity of the post-processing needs and consequently the complexity of the post-processor tools render them rather an unfavorable option for designs. Now, another need is for the designers to be able and check how a design really looks like in the real world. And with this, we mean how it looks like maybe with some more advanced rendering options and how they really look like under the loading conditions. Another need is for both CAD and CAE engineers to get a quick and rough estimation of the impact that the change on the design might bring. Now, there are two modes of communication that we wanted to consider. The first one being the direct communication, where we want to have people communicate live, find themselves in the same live session and interact with each other. In this case, we also have our software for collaboration, NERIC, coming to play, and there is also the option and solution of the virtual reality. But we also want to take into account the mode of the asynchronous communication, in which case engineers want to interact with each other at their own times via exchanging some files. Let's have a look at some use cases, how DEAN can be used. First case, imagine that we have a CAE analyst and they use Meta in order to review a model and the CAE results calculated on the model. So they take a look at the results and they have some issues that they want to communicate to the designer. So they inform the respective designer in order to join them in the live session using DEAN, so that they can get to see in DEAN what the CAE analyst actually sees in Meta, and all actions applied from the analyst in Meta will be reflected to DEAN for the designer to have a look on. So the analyst can show the results, comment on them, animate or explain them in detail, and they can discuss on them. Throughout this, there are also some tools offered for the designer. For example, there is the option to be able and save and record the session to have for future reference. There's also the capability to export the model. For example, if it is something that includes also some countermeasures that the CA engineer has added, or if the deformed model wants to be used, there is the option to export it in CAD format so that the designer can further work on it in any CAD software. And there is also the option to load new CAD designs inside the tool while still in this live session so that they can directly discuss on some new ideas and proposals. In this use case, there is no further need for any other means of communications like phone or emails. Everything is done directly in this live collaboration session between Meta and Dean. Now coming to the second use case, it's more or less the same as previously, up to the point that the analyst wants to share their comments, their feedback, but they want to do it to send the file and so that the designer can do it on their own time. So they add everything directly on the model, on the 3D model, on the history results, any comments, they mark areas, whatever they need to share, and they save it under one single file under one single MetaDB and share this file with the designer, who can go then and open it at a later time, have everything included, and can review and maybe proceed with some actions, but also add some comments, some feedback back for the analyst, save another version of the MetaDB file and send it back. And this back and forth this cycle of back and forth communication with exchange of MetaDBs can be realized as many times as needed. Again, the same tools are offered here and could be used by the designer. For example, the capability to export the model as in CAD format to be used in some further CAD software. Now, in the third use case, we have a CAD and a CA engineer that would like to check a specific model and check the gaps in a specific location of the model and how they look like in some real-world conditions. So they can start a collaboration session with Dean. They can also optionally have this with the virtual reality solution and find themselves inside the same virtual meeting room and get to see the model with using photorealistic rendering, have a more real feel approach, and get to see them also in different operation conditions and check if the gaps are according to their estimation. Now coming to the fourth use case. In this use case, we have a specific part which is analyzed by a series of CA engineers from different departments, from the crash department, then from some other engineers that are doing CFD, fatigue, or NVH analysis. And each engineer reviews the corresponding results of the corresponding analysis, collects some comments and feedback, and sends it back to the responsible designer for this part. Then the designer collects everything and creates some suggestions, tries to find a solution merging all the issues, all the feedback, and then they use Dean in order to do a collaboration session again where everyone can participate and discuss directly on the model, discuss on possible solutions and on possible further actions. Now let's have a look at the features of Dean. First of all, on the interface, you can see that it differentiates itself a little bit compared to the rest of the beta suite. We try to follow a more simplistic approach in order to offer the functionality needed in an interface that is very intuitive and demands no learning curve. There are some menu tabs on the top, and there is one single list with all entities in the database. Then we have the bottom area with widgets to handle the results visualization and the animation, the focus actions on the right, and some more auxiliary options on the top. Regarding import and export, the concept is to be able and input the main workflow is to input data using post-processor databases and mainly MetaDB files where everything will be included, CA results, model, and everything concerning the feedback on it. There is also the capability to import animator databases, and then there is also the capability to import and export CAD files, CADs to import, STL, VRML, JT, or even CAD and CT translated files can be directly imported. And it is also possible to export in one of the commonly used CAD formats like STL, VRML, 3D XML, JT, etc. Now coming to model handling, there are some options in order to handle the view, to have a photorealistic rendering applied, to have a contour displaying the CA results on the model or animating them. There is also the virtual reality mode. And there is a palette of tools offered targeting at offering the means to add comments, to add feedback directly on the results so that the analyst or the designer can mark areas on the model, add some comments pointing at these areas, perform any necessary measurements, or create some sections, cut some sections in order to help explore the model better and check some more internal areas. What is important is that all these entities are shown in one single list so that the user does not have to change among different tools, among different windows. Everything is in one single list with the entities on top and the setup, the settings for the options for these entities right below. Also, for the need to capture an image of the model and the results with the comments, or to record a video with some animation of the loading, or with to record a video with some actions applied on the model, there is also the capability to save and export such images and videos. Regarding collaboration, any combination of modes is possible, meaning virtual reality with the standard desktop usage application, or DIN and Meta, DIN and DIN. All these combinations are possible. There is full actions compatibility between Meta and DIN, and this means that in a live session, whatever is realized in Meta, even things that are not that are only offered in Meta, more advanced things, their outcome, the result will be reflected directly in the DIN interface, in the DIN view as well. And also actions applied in Meta, when saved in a MetaDB and shared with DIN, they will also be available as entities in DIN as well. And another important note here is that the live collaboration is done through the exchange of meta session commands, so that there is the minimum requirement in terms of network bandwidth. Now let's have a look at the demo video showing how a designer may use DIN. Imagine we are the designer and we receive a MetaDB with a design that we have created and some comments from the CA analysis, from the CA analyst about this. So we can isolate the area that we are interested in. And there is a series of predefined views saved by the analyst so that each view can show us a specific location where we want to share some comments, where there is an issue. We go to the first one, and we make use also of the plane of the cutting planes in order to have a better look on this inner location. There is a message here from the analyst that there is a high concentration of stresses, and this is why the analyst tried to make some wider ribs there in order to reduce the issue. We can go and measure the width of these new ribs so that we can take them into consideration. We can try to find some designs and to use this new rib width in this new design. And in order to help us do this, we can also export this this model with this adjusted model from the CA analyst as in CAD format, so that we can open it and further work on it in our CAD software. Now we can also add a reply directly on the location of this issue with our feedback on this specific issue, and let's say let the CA engineer know that we have seen this and we will take this into account. We will consider this new width. So this new text is directly placed on the same location, and it makes communication on each separate issue realized in a more comfortable way. We can go to the second location as saved by the analyst, and this is again another location with high stresses. The analyst asks if there is any alternative design that we could use in order to help in this direction. And imagine that we have created an alternative design that we want to show to the CA engineer and discuss on it or have him analyze it. So this new design is imported inside the same session, and thus it can be included in the saved MetaDB that we as designers will save and send back to the analyst. And again, we write a reply for this case, again on the location of the issue, so that it is directly attached to the specific location. And you can imagine that this series of saved locations with issues could go on with as for any locations that need to be discussed. And at some point when we want to share our feedback with the engineer, with the CA engineer, then we place everything together. This is also an example of using the single entities list and how comfortable it is to work with it. You don't need to go into other tools. You can also filter, as in this case, to get just the text boxes with the feedback, so that we can, let's say, change the color of our own reply and differentiate it from the original comment. And now that we have everything, we can, let's say, we can also apply rendering for the new design and save it as a new version of the MetaDB to send it back to the CA engineer. Now, comparing some different formats, some different solutions in order to be able to share CA results and with non-CA experts. We have the 3D PDF, the GLB and GLTF, and MetaViewer and DIN. In regards to the capabilities offered and the interface to handle these capabilities, GLB and GLTF, let's say, can offer the fewest capabilities and in a not so well organized interface. 3D PDF and MetaViewer rate better in this sense, but Dean offers the best solution as it is specifically designed to offer these capabilities for these needs as mentioned in the most intuitive way. Now, in terms of file size, MetaViewer and Dean make use of the compressed MetaDBs, which can result to file sizes 10 times smaller than the uncompressed formats of 3D-PDF and GLB. There is a series of functionality like states and animation handling, multiple results handling, and photorealistic rendering. All these functionalities may be missing from one or more of the other solutions other than Dean, or may only be partially available there. And Dean offers some extra features as well, like the bidirectional communication, meaning the capability to have this exchange back and forth of MetaDBs, including everything and the comments, the results and the comments feedback on them, and doing this as many times in both directions as needed. The concurrent collaboration and the virtual reality solution. This concludes my presentation, so we have some time for any questions that you might have.